All right, Mathletes 4.2 inverses and one-to-one functions. So function is one-to-one if each input has its own output. A mapping diagram here, you can see this is not a one-to-one function because this single output has two inputs here, so that's not going to be one-to-one. This example being names and addresses, you can have two people living in one house, but if I ask you, what is the person living in this house, you can't tell me because there's two solutions there. Well, a one-to-one function is every single input has a unique output. And an example could be names and social security numbers. If I know somebody's social security numbers, I can find their name and vice versa. So how do we check for a one-to-one function? For a table, just look for every x value. It has its own y value. And graphically, we're going to have the horizontal line test. So vertical line test for a graph told us if graphs were a function. Well, now if we have a graph, we can trace horizontal lines. If it only passes at one single point, then we know it passes a horizontal line test. It is then a one-to-one function. So, for an example, f of x equals the absolute value of x is not a one-to-one function because when the solution is 1, our inputs of -1 and 1 both gave rise to a solution of 1, so it doesn't have a unique thing. So on a graph, you can see when you draw a line of an absolute value graph, you're going to intersect at 2 points, so it's not one-to-one there. And again, on a table of values, if you notice that for your input of x's, okay, -2 is mapped to 2, and so is 2 being mapped to 2. So if we're trying to go backwards and we have an x of 1, well, that means one absolute value of 1 is equal to 1, and absolute value of -1 is equal to 1. So we don't have a one-to-one function there. So the notation that we're going to use when we're talking about inverses, okay? So if f of x is your function, f -1, this is a superscript, kind of like a square or something like that, is the inverse function of f of x. So if a function f is one-to-one, then it has an inverse function. Not all functions will have a inverse function. One big idea here is the domain of f, domain of your function, is equal to the range of f of -1, and the range of f is equal to the domain of f of -1, your inverse. So if you think about this, okay, and this being your x and this being your y, and you have some function, f of x, defining things going this way, okay, this would be your domain for your function, and this is your range. Well, if your inverse of your function is taking these values and giving you a way to go back to your y's, you can see that for this area, this is your domain of your inverse, and this is your range. So hence you can see that the domain of f is the range of your f inverse, and your range of f is the domain of your inverse. All right. So example, say whether each relationship is a one-to-one. If so, find its inverse function. So in example A, we see that every input has a unique output. So it is a one-to-one function. So if this is equal to f of x, f prime of x, we know that they're just switched around. So your input would be the point 1, your output is 3. Your input would be -1, your output is 2. Your input would be -3, and your output is 1. So just switching these values, right? And then we would have -5, 0, and that would be the inverse function. So our next one, B, we notice that at 3 is 1 and negative 3 it's 1. If you think about graphing that, we have at 3 it's 1 and at negative 3 it's 1. That's not going to pass our horizontal line test because our inputs don't have unique outputs. These are the same outputs. They're not unique, so this is not a function in B. Okay, the graph here is a one-to-one function. Okay, to draw the inverse function, we can just flip-flop our x and y, and we should note that all inverse functions will be a reflection of the graph across y equals x. So easiest way to do this is, so if 2, 5 is a function, I know that 5, 2 is of its inverse. So I come over to 2, 4, 5, up 2, and I get that inverse point here. 0, 1 becomes 1, 0. Negative 3, 0 becomes 0, negative 3. And negative 2, or negative 4, negative 2 becomes negative 2, negative 4. So it would be off the graph down there somewhere. But I would get this graph. So, sorry, negative 2, negative 4 would be right here, and it'd be right there on the graph. And you can see that this graph here in the black is a reflection across the red line of our green graph. So we'll always notice that when we're graphing our functions and our inverse functions. So, to find an inverse algebraically, we're going to follow these 4 steps all the time. So first thing you want to do is interchange the x and the y values, reverse each ordered pair. Okay, so if it is just f of x, you're going to replace f of x with x and then put the y value in there. Then you're going to go ahead and solve for y in terms of x. So you're going to isolate y by itself, then replace y with f negative 1 of x, and then you can check that f of negative 1 of x should be equal to x, so you'll check that, and then you'll check that f of negative 1 of f of x is equal to x, and that's how you can verify that something is an inverse of a function. So let's go ahead and do one. So f of x equals 1 minus 3x, so I know that this in point slope form, this has a y-intercept of 1 and a slope of negative 3. So down 2, 3 over 1, down 2, 3 over 1, down 2, 3 over 1. And I'm going to see that any equation of just a line is going to be a one-to-one function. Okay, passes our horizontal line test. So it is a, so I want to find its inverse. So I'm going to replace, so if this is y equals 1 minus 3x, I'm going to replace my x and y. So I get x is equal to 1 minus 3y. And I'm going to solve for y. So subtract 1 from both sides. And then I'm going to divide by negative 3. So then I get y is equal to negative 1/3 x plus 1/3. And then replace y with f prime of x is equal to negative 1/3 x plus 1/3. Okay, so I can go ahead and graph that, and I can see if I'm graphing this, I have a y-intercept of 1/3. Okay, and then I'm going to go up 1 over 3. So actually it's a negative slope here, so we got to do a down 1 over 3. And I'm going to be here, down 1 over 3, and then I'm going to be here, and up 1 backwards 3. So then I get a line that's going to be off in this direction. Okay, and as I can see, that this is a reflection across the y equals x line. So in example 2, we're given f of x equals x squared plus 9. So is the function 1 to 1? Well, if we just look at this first piece and we see that it's x squared plus 9, we expect a parabola. Okay, well, the parabola is not going to be 1 to 1, but notice here we're going to restrict our domain for x is just greater than 1, so we're only looking at this part of the graph, and that part of the graph will pass our horizontal line test. So it is a 1 to 1 function. So to find our inverse, we're going to switch our x's and y's. So I'm going to get x is equal to y squared plus 9. Okay, so I'm going to subtract 9. So we get x minus 9 equals y squared. Take the square root of both sides, and I get the square root of x minus 9 is equal to y. And technically this is plus or minus speaking, but now let's go ahead and look and state the domain of f and f of negative 1. So the domain of f of x is for all real x's such that, well, we had to make sure that x was greater than or equal to 0. If x was greater than or equal to 0, well then for our range of that function, I need to understand that the range of f of x, if the smallest value I can put in here is 0, that means the smallest value that my f of x can be, its output, its range is going to be 9. So this is going to be for all real y's such that y is greater than or equal to 9. Okay, so remember that these are going to interchange here. So if this is my function, plus or minus square root of x minus 9 equals f prime of x. So if that's my function, if I want to find my domain and range for this, I need to understand that they interchange. So my domain of f prime of x should be here interchanging my y's with x's. So this is going to be for all real x's such that x is greater than or equal to 9. Well, I see why x in this equation has to be greater than or equal to 9, because I cannot have a negative under my radical. Now for my range is going to be for f negative 1 of x is going to be for these, but interchanging my y's. So it's going to be for all real y's such that y is greater than or equal to 0. So because this is greater than or equal to 0, my real f prime of x, I don't need to worry about this negative when I took the square root, because y's have to be greater than 0 because it's adopting the domain from our original function to make sure that it was a 1-to-1 function. Okay, so f negative 1 of x is only equal to the positive square root of x minus 9. So number 5, next example here, B, verify that f of x and f prime of x are inverses of each other. So if we do the composite of f inverse of x, if these are inverses, it should be equal to x. So we need to test this. So I do f of the inverse square root of x minus 9, which is equal to square root of x minus 9 squared plus 9, which is equal to x minus 9 plus 9, which is equal to x. Check, I'm good there. Next piece here is I got to make sure the composite function of f inverse of f of x is also equal to x. So I do f inverse. F of x is x squared plus 9. And then I substitute that in for the inverse. So I get the square root of x squared plus 9 minus 9. Well, this is just going to the plus 9 minus 9, then we get the square root of x squared. Well, that's just equal to x. So check. We have shown and verified that fx and f inverse of x are indeed inverses. So number 5 here, the inverse function of the 1, 1 function. So I want to find this inverse, and I want to state the domain and range. So to find this inverse, I'm going to let x equal square root of y plus 4. So square both sides, I get x squared equals y plus 4. Subtract it, and I get x squared minus 4 is equal to y. So f inverse of x is equal to x squared minus 4. So first thing I want to do is I want to state my domain for f of x. So my domain, I got to remember that this value can't be negative. So I got to have x plus 4 greater than or equal to 0. So x has to be greater than or equal to negative 4. So my domain for f of x, it's for all real x's such that x is greater than or equal to negative 4. So with the square roots, I don't have a plus and minus in front here, so I know it's got to always be positive as my output. So my range of f of x is going to be for all real y's such that y is greater than or equal to 0. Because at negative 4, you would get the square root of 0, which is 0. So it's inclusive there. So I need to remember for my inverse function, okay, that those should carry over. So my domain of f negative 1 of x, domain's always dealing with my x's, but I'm going to take the expressions for my y here, because what was my range of my f of x is now my domain of my inverse. So it's going to be for all real x's such that x has to be greater than or equal to 0. That's going to make sure that this stays as a one-to-one function because it's a squared function, x squared minus 4. And I know a parabola wouldn't pass a horizontal line test, but now I see I get my restriction in here, and that's going to satisfy that horizontal line test in that one-to-one function. So then my range. So the range will come from my domain here, but I'm still talking about y. So I got to do f of negative 1 of x for all real y's such that, so y is greater than or equal to negative 4. Okay, so I know that as I do this, this is a function. It has a y-intercept at 4, so that's going to be its vertex down there. So I'm going to get values above that concave up because I got a positive a value there. Let's look at our last example here, 6. So find the inverse of this one-to-one function, 4 over 2 minus x, state the domain and range of both. So again, I'm going to say x is equal to 4 over 2 minus y, and I'm going to multiply both sides by 2 minus y. Or actually, I'm going to put this over 1 and I'm going to reciprocate things. So I'm going to do 1 over x is equal to 2 minus y over 4. This gets somewhere, so I want to isolate this y. So I'm going to multiply both sides by 4, so I get 4 over x is equal to 2 minus y. I'm going to subtract 2 from both sides, so I get 4 over x minus 2 is equal to negative y. Multiply by negative 1, and I'm going to get 2 minus 4 over x is equal to y. So this is my inverse. And I get 2 minus 4 over x. So I need to state my domain and range. So my domain, my function here is of f of x. Domain of f of x is for all real x's such that x cannot be equal to 2 because I can't divide in the denominator. Okay, so my range for this so my range, got to think about my rational functions. This is going to be bottom heavy here. So that means it has a horizontal asymptote at 0. So there's nowhere that this can be 0. So it's going to be the range of f of x is going to be for all real y's such that y cannot be equal to 0. Because we're not going to be able to get 0 in there because we don't have a factor with an x up top there. So then as I state my domain for my inverse, the domain of f negative 1 of x is going to be for all real x's such that x cannot be equal 0. And that should make sense because when I look here, I got an x in the denominator and I can't have that being 0, and the fact that it's copied from your range of your original function. So now your range of your inverse is for all real y's such that, again, I'm borrowing from my domain, such that y cannot be equal to 2. And that should make sense because the only way I can get this function to be equal to 2 is if this right side is equal to 0. Well, I can't divide by 0, and 4 divided by nothing is 0, so there's no way that I can get this function to be 2. So there's my domain and range for that. So highlight any questions you might have and bring in class tomorrow.